Hi everyone, in today's episode of Gaffer and Gear we're going to be looking at the Velvet Kosmos 400 watt RGBWW Fresnel. Now I was meant to review this light about 3 months ago, but a few things went wrong. Number one, it got sent to the wrong address. It actually got sent to somebody's holiday home in some place called Victoria Valley. So by the time they took a holiday and found this on the veranda, it had been sitting there for about 3 weeks, which is why it's covered in this sort of dust. That's actually the cardboard box it was in was starting to break down. The next thing that went wrong is my spectrometer needed repair. So I couldn't actually take any readings, or more to the point, I'd taken a whole stack of readings that I didn't trust. So that's why it's been such a delay in bringing this review to you. Now the unit is 400 watts, RGBWW. Let's take a look over the body. We've got a Lumen Radio receiver. We've got a Bluetooth receiver. We have a USB port in for firmware updates. We have our Nutrix power in and out, so the power transformer is built into the light. We have 5-pin DMX in and out. We have a nice big on-off power switch, and we have a DC 3-pin input. And the navigation system is a touchscreen. The light is a very solid construction. The bulk of the body seems to be made of some sort of industrial plastic or possibly even a carbon fibre. It has a solid tubular steel yoke with a single ratchet handle lock-off and a very solid locking clutch. On the stirrup is a cable holder with a carabiner locker which can't accidentally be removed. The buttons on the back are protected by a tubular crash cage. The outermost part of the light has a built-in rubber bumper, and the bottom of the light has a steel exoskeleton. Alright, so let's do a very quick run through of the whole system, and it's going to be very quick because this is really simple to use. Alright, so we're in our CCT mode. Now you can select your mode down the bottom here by pressing. So it's our HSI, RGB and Jels library. Let's go back to our CCT mode. Now in the top here you can select tungsten or daylight presets. So very straightforward. Next to that in the top corner here is your presets, so you can save presets and restore them from this menu, so pretty straightforward there. Alright, so your flood spot is controllable via the slider here. Okay, so it actually goes from, 15 degrees up to 56 degrees, so it's got quite a nice flood. Now you can also operate that manually via the button here, so to select your zoom, press the button and you can operate it via the knob if you're not keen on touchscreens. Now if I press that knob again, it'll toggle to brightness, so I can use that to adjust my brightness, and it adjusts in 0.1% increments. The Kelvin range, you've got 2,500 Kelvin all the way up to 10,000 Kelvin with a plus minus green. Okay, let's swing across to our next mode, which is our HSI. Now in the HSI mode, you can select your Kelvin and then your Kelvin base that you can saturate and desaturate from. So at the moment it's set to 5,500, but we can change that, so 5,600 there. Okay, you can adjust your saturation and of course adjust your hue angle. So very, very basic to use. RGB is pretty straightforward. Your Jels library, you've got a choice of Lee and Roscoe Jels. So let's go to the list. Let's go alphabetical. You can choose alphabetical or color. View list, and now we can scroll through the list. So as you can see, incredibly easy system to use. Okay, let's get out of there. Okay, next up is our settings. So the settings is a very straightforward menu. Okay, so DMX. So you can select your address up the top, very easy, and you can select your profile with the bottom knob. And the one thing I like is it actually tells you what channel does what in the profile. And you can select whether it retains its last command or what's the other option there, or it goes to local. So very simple. If you want to select how you're operating, if you want to get into Lumen Radio, you just press remote and select Lumen Radio. And now it's linked to my Lumen Radio controller as soon as I find where I left it. Okay, so now I've got Lumen Radio control. It's a very, very simple system to operate. Incredibly simple. All right, let's get out of this menu. Okay, you can select your curve, so whether it's linear, logarithmic, or exponential. Fan, now you can toggle between, what have we got there? Full speed, silence, priority, and dynamic. Okay, and that's pretty much the whole system in a nutshell. Now the next feature with this light is it can run off batteries. So I've got two V-mount batteries on the bottom here. Now if your mains power gets pulled, it automatically switches across to battery operation. Now you've got a choice of V-mount or gold mount, and it is a removable plate. Okay, so it's solidly built. It's got some nice protection here for the buttons at the back. The whole thing comes in at 9.8 kilograms, that's including the stirrup, so it is a bit of a beast. Now, is it worth the money? Well, that comes down to how bright it is for a lot of you. So I've taken some readings at 3 meters. So at 3 meters at 3,200 Kelvin, the unit comes in at 2,950 lux. So to give you some idea, that makes it way brighter than a 1K tungsten Fresnel. Not quite as bright as a 2K tungsten Fresnel. It's about 82% or 81% the brightness of a typical Studio 2K Fresnel. Now in full spot, that jumps to 12,100 lux. Now when I took my daylight readings, I got 4,460 lux in flood. Now to give you some idea, that makes it way brighter than a 575 HMI Fresnel, but only about 65% the brightness of a 1.2K Fresnel with a big lens. And when I spotted it up in daylight, I got 16,900 lux. Now red came in at 504 lux in flood and 2,300 lux in spot. Green came in at 1,000 lux in flood and 4,230 lux in spot. And blue came in at 310 lux in flood and 1,310 lux in spot. Now in terms of its optics, the Fresnel performs the way that I'd expect a Studio 2K to perform, or maybe a 1.2K HMI. So it floods and spots very similar. And it cuts a flag in much the same way. Similar edge patterns to what I'm used to. However, its barn door cutting is pretty average. When you do a barn door cut, it's hotter in the center of the barn door beam than it is around the edges. Now let's have a look at how it goes in terms of color fraying. So I go through my Kelvins, there's no color fraying. If I go through my colors, there's no fraying on the edge of the beam. So what I mean by fraying is it's the same color all the way through. Now let's go through what I think are the negatives, and I've already hinted at the first negative, and that is the barn doors. So the problem with the barn doors is they're painted with a highly reflective paint. Now let me show you just how much of a problem this is. So we're going to point the light off to the side, and when I tilt the barn door in, it'll illuminate the back wall. Now you can fix the barn door issue with a can of matte black spray paint. So that's what I'm going to be doing after the review. But the next problem for me is the cooling fans. No doubt you've probably heard them. I would be reluctant to run this within about 4 meters of a microphone. Now here's the thing, I'm running it in the quiet mode. Alright, so let's go through the positives now, and pretty much everything else with this thing is a positive. It's really well built, it's really reliable. I can't really fault much with it. Now, if I had to point something out as a hero for the positives, it would be the Lumen Radio DMX. It is fantastically smooth. So let's have a bit of a play with that. Now, one thing you can do with the DMX is flood spot. Now, with your flood spot, it flood spots at the same speed. So, for example, you can't program in a 5-second spot. It'll just flood spot at the pace that it flood spots here. Now let's have a look at how smooth it fades. So let's do a 5-second fade to black. And again, this is 8-bit profiling. Okay, let's change that to a 2.5-second fade. And let's do the same with a 1-second fade. Now let's do a CCT sweep from 2500 Kelvin to 5600 Kelvin over 5 seconds. Now we will sweep back the other way in 2.5 seconds. and back the other way in 1 second. Now let's crossfade in a hue. Let's crossfade back the other way in 2.5 seconds. And crossfade the hue back in 1 second. Now the profiling is actually quite good. Now one thing I do like with it is it's got a change mode. So there's nothing unusual about that. Other lights have change modes. So a change mode is a mode where one channel selects whether you're in CCT or HSI or RGB, for example. So you can change your modes without having RDM. Now what's good with the change modes in this is the modes that you can select are dual purpose. So you can change to a CCT HSI mode or a CCT RGB mode or a Jels mode, for example. It has combination modes. The next thing I want to show you is the barn door catch or the barn door holder. So you've got a little metal groove up here, which the barn door slots into, and down the bottom here, you've got a spring-loaded release. Now you've got magnets here, here, and here, and here. So to put the barn doors on, it's as simple as this. Now those magnets give you a very good positive feel when you rotate the doors. So for example, we can put a slash in, and we can shake the light around. The barn doors are not going to roll because the barn doors are being held in place by the magnets. Now let's go over the power draw of the unit and the battery operation. Now the unit doesn't pull as much power in tungsten as it does in daylight. So in tungsten it only pulls 310 watts AC power draw. So once again, it's almost as bright as a 2K tungsten, but it's only pulling 310 watt. Now in daylight, 5600 Kelvin, it's pulling 392 watt. Now here's the thing with running it off batteries. It seems to be limited to a 300 watt power draw. Now because in tungsten the thing's only pulling 310 watt, it is almost imperceivable because it's only 3%. So if I toggle between AC and DC power here, you can't really see any change in brightness at all. But if I flick it to daylight, 5600 Kelvin, and I change from AC to DC, you can see the brightness drop slightly. Now, if you're running it in color mode, at no point is it pulling more than 300 watt. So it doesn't make any difference to brightness whether you're in AC or DC mode. All right, so before we get into the technical data, I just want to go over how I think this light is tracking its white point. Now it's not tracking the Planckian curve like most RGBWW lights do. It's doing something very unique and something that's arguably very clever. All right, so if you have a look at this graph here, you can see a curved line, and we call that curved line the Planckian curve or the Planckian locus. So that is arguably what we perceive as being white light. Now if you have a look above that line, you can see some points marked D50, D55 and D65. Now these points are standard light markers based on direct sunlight measurements. Now what I mean by direct sunlight is sunlight without any cloud or without any overcast. So D55 is based on readings of sunlight in mid-morning and mid-afternoon, and D65 is based on midday sun with no overcast or no clouds. Now these points are on a different curve called the daylight curve, which starts at 5000 Kelvin and continues onwards. Now what this light does is it tracks the Planckian curve between 3000 and 4000 Kelvin, and then it slowly deviates upwards until it meets the daylight curve, and then it tracks the daylight curve. Now this sort of makes sense because this is a hard light and the daylight curve is based on light values of hard sunlight. So the pros of this system is if you're working in a tungsten environment, this will blend in nicely. If you're working in a location that has hard sunlight coming in and you're adding to it with a hard light like this one, then this is going to work superb. But here's the downside. If you're in a studio environment running, say, things like sky panels or other RGBWW lights that track the Planckian curve, then you're going to need to add some magenta to this light to get it to match. Okay, let's go through all the data I've collected, starting with CCT accuracy. Now, the higher the CCT value you enter into the light, the more it's going to be out by. So it tends to read under in its high CCT values. All right, so below 3000 Kelvin, this unit is typically accurate to plus or minus 17 Kelvin. Between 3000 and 4000 Kelvin, it is very accurate, typically only 20 Kelvin over. Between 4000 and 5000 Kelvin, it reads under by typically 46 Kelvin, and between 5000 and 6000 Kelvin, it is out on average by minus 158 Kelvin. All right, let's have a look at the TM30 color vector scores. This thing scores pretty well. Below 2950 Kelvin, it scores 95. Between 2950 Kelvin and 3450 Kelvin, it scores 94. Between 3500 Kelvin and 5100 Kelvin, it scores 93. And from 5150 Kelvin to 6000 Kelvin, it scores 94. Now, even right at its very top Kelvin, which is 10,000 Kelvin, it still scores a 90. Okay, so let's go over the white point accuracy, or delta UV. Now, below 3000 Kelvin, this thing is typically out by plus 0.0010 delta UV. Between 3000 and 4000 Kelvin, it is typically out by plus 0.0008 delta UV, which means it's off pure white by about the equivalent of 1/3 of a 1/8 gel, so very, very accurate. Between 4000 and 5000 Kelvin, I don't want to give a figure because it slowly creeps up from the Planckian curve up to the daylight curve. Now, between 5000 and 6000 Kelvin, it is typically out by plus 0.0035 delta UV. So that means it's off the Planckian curve by a little bit more than a 1/8 correction gel, but it is tracking on the daylight curve. Now let's take a closer look at some of our kelvins, starting off with the lowest Kelvin we can dial in, 2500 Kelvin. When I dialed in 2500 Kelvin, I got 2485, with a TM30 color vector score of 95% color render, with an average 103% saturation. Here are all the individual CRI scores, and they're all above 90, and this is the wavelength. When I dialed in 3200 Kelvin, I got 3209. With an SSI score of 82. Here are the individual CRI scores. R9 and R12 are below 90. TM30 color vector score was 94% color render with 102% average saturation. And the white point accuracy was out by a delta UV score of plus 0.0012, which means the light is off by roughly 1/2 of a 1/8 correction gel. When I dialed in 4400 Kelvin, I got 4370, with a TM30 color vector score of 93% color render, with an average 101% saturation. Here are all the individual CRI scores. R9, R10 and R12 are all below 90. Here is the wavelength. And the white point was out by a delta UV score of plus 0.0014. which is well under a 1/8 correction gel equivalent. When I dialed in 5600 Kelvin, I got 5462, with an SSI score of 74%. The TM30 color vector score was 94% color render, with 101% saturation. Here are the individual CRI scores, and only R12 was below 90. This is the wavelength. The delta UV point is 0.0035. So this is where it sits in relation to the Planckian curve. However, when we plot the same information over the daylight curve, it is almost spot on. Now, when we dial in the light's top CCT of 10,000 Kelvin, we get 9159 Kelvin, with a TM30 color vector score of 90% color render, with 96% average saturation. And here is the wavelength. Now let's have a look at how this thing performs in its HSI mode. Red was smack on at 0 degrees. Green was smack on at 120 degrees, and blue was right on the money at 240 degrees. Yellow, which should be 60, came in at 49 degrees. Cyan, which should be 180 degrees, came in at 226 degrees. And magenta, which should be 300, came in at 260 degrees. Now let's take a look at how accurately it desaturates the colours. So I did my testing at 50% desaturation at 5500 Kelvin with the meter set to D55. Now, looking at all my numbers, I've come to the conclusion that this thing is not desaturating logarithmically. It's desaturating linear. So that's out of step with the bulk of our other lights. So if you want to match this say, desaturated to a sky panel, with a sky panel desaturated to 50%, you want to dial in 75% saturation on this unit. Okay, so red came in at 13 degrees with 24% saturation. Green came in at 106 degrees with 20% saturation. Blue came in at 242 degrees with 34% saturation. Yellow came in at 50 degrees with 32% saturation. Cyan came in at 224 degrees with 37% saturation. And magenta came in at 264 degrees with 40% saturation. I'm Andrew Locke. See you on the next episode of Gaffer and Gear.